Okay, I'm starting the contest late, guys. I'm starting the contest late. It's already 8:10, 5 minutes late. It should be fine. 5 minutes late should be fine, right? Let me remove some tabs, some unnecessary tabs, so that I can have some privacy. Okay, it's an unrated contest, right? So I think it should be fine. I'll share my screen now. Oops, I don't want. I want privacy. I want my privacy. It's fine. I don't think there is anything weird. CF1057 is it? Due to, let's see how many problems I can solve, because you guys are learning from me, right? So you guys should be able to. I should be able to do well. Fuck this. Let me read the problem parallelly. You guys can see my screen, right? I have zero viewers. I hope it stays so. Hi, bro. I'm streaming some contest. I will call you later, I guess, at 10 o'clock. I'm just streaming some news and two contests. I will upload it later. Yeah, yeah. I started 5 minutes back late, so I think I will upload it after the contest ends. I'll just upload it. So it's just due to I started 5 minutes late, but still, yeah, I can talk to you later. I guess that's fine now at 10. Yeah, at 10 I will call back. Apple is arranged in a circle. Each tree bears exactly one apple, and the beauty of the apple. N apple trees arranged in a circle. Each tree bears exactly one apple, and the beauty of the apple in the ith tree is bi. You start in front of tree 1. At each tree, you may choose either to eat the apple or skip it. After your choice, you move to the next tree. From the tree I, you move to tree I plus 1, and from tree n, you move back to tree 1. This process continues indefinitely as you move through the trees in a cycle. However, you have a specific condition. You may only eat an apple if its beauty is strictly greater than the beauty of the last apple you ate. So it is like some increasing sequence right now. Uh, you can take one, two, three, and you could eat apple on tree one. You cannot eat apple on trees two and three because their values are less. You're allowed to skip an apple when my my laptop got switched off, and then I'm making a new. I mean, I charged it now. So this difficult data structure, we are trying to maintain this one. How can I do that? Range parent for each color I will maintain this, and then we have what? 5, 1, 2, 3, 4. Okay. We want the first thing that is not equals to this. Okay, let me also have that thing. We'll go over all L indices. We'll go over all L indices. And then we'll add a parent. How to define recursion well. Okay, we have j equal if extend the time, please extend the time. Yeah, extend it so that I can solve that. So can I solve this shit? This 10 seconds and this 1024 is scaring me. Is it that difficult? Was my idea wrong? I don't know. We also want the answers of the right subtrees, okay? We also want answers of the right subtrees. So for a node V, let's say answer with its parent is number of parents on the right side and all the right subtrees of the parent. Let's say that's what we store here. Then what do we want? As we go above, we want answer of this plus answer of this, parents after that, and parents children, answers of parents children after that. That's what we store. Wait a minute, except these three things, It's like right subtrace, okay, and then I will have left subtrace too. So what is B from here down value? What is right subtree? Parent, number of things, number of parents after this, is it odd or even? And all the sum of parent children, and this is left subtree, okay? I will add R of n here itself. Initialization. Let's say I want LCA too. Is it all right? Is it compiling? Fuck it. I can't do this within the contest, but I hope I can do it just after the contest. Okay. This we can do with prefix sums. Hello, can you hear me well? Guys, you guys can hear me well, right? So this is screencast, which is already done. Like I have, if you go behind, below, before, if you go forward, how many did I solve? Also me solved four, but then I am almost done with F. I think I'm almost done with F. So let's see if I'm actually done with F or not. So guys, to reduce your fear, let me tell my F solution. Let's see if I have actually solved F or not. Okay. I will tell the idea a little bit and then I will try to explain other problems. Is that fine? So just stay there now because you guys can see the video afterwards. But for now, like the video too, like the video and stay for my F. So what I have done for this F was they told an array A, an array B is cute. See, understanding the problems is not that difficult. So first let's understand the problem. An array of length M is cute if there does not exist this four integers, is what they told. Such that bi equals to bk and bj equals to bl and bi not equals to bj. So what they are meaning is you cannot have a red here and then a red here and then a green here and then a green here. That's what they mean. Okay, did you guys get it? Like the problem statement, like no, what is a cute array? Cute array means you cannot have red and then green middle. That's what they said. Is cute array clear? Guys, you're following me, right? Yeah, Tejas Katare, follow me. Yeah, I remember you from some comments, but yeah. So that's what they're telling about cute array. And then they're asking you some query. The query is given a range, you want odd number of, you want sum of odd occurring values. Okay, if this is the range, 3 is odd, right? 3 is coming odd number of times, you want 3. Plus, so the query is simple. You want to add the values that are occurring odd number of times. You want to add the values that are occurring odd number of times. So means if it is 1 1 2, 2 is occurring odd number of times, so the answer is 2. If it is 1 2 2 3, answer is 1 plus 3. Is the query simple? Guys, take a breath. Did you get what is a cute array? And did you get the query? I have solved all of them easily. I don't think C and D were hard. Like C seemed a bit hard, but D is not hard, I guess. D was direct DP, simple DP. Like I have explained them well. C back afterwards. But for now, let me explain F. Okay. What is a cute array? Cute array means you won't have a value red here. You won't have a value red here and a red here, and then you won't have green here and then green here. That is a cute array. So see, all the problems were done in the past. You guys are not viewing. I think Tejas Katre, yeah, that is not possible. Tejas Katre, that's not possible. Tejas, AB is not possible. Okay. So what I have done was, so now it appears to be there is a structure, right? 1 minute. This means there is a structure. What is the structure? If you see, if you see, if you see some color and some other color, the other color appears entirely in between. Okay, the other color entirely appears in between or it appears sidewards. Do you get that? Do you get that? Like what I'm trying to show here is, let's say you have some green. Okay, you have some green, all the red will appear somewhere in between. If this happens, what I will do is I will take red and then I will keep an edge from red to green. I'm trying to see them as a tree because the cute array is cute, we can see it like a tree is the idea. So guys, It is already uploaded. You can go behind. You can go behind to see. But Tejas, you understanding the idea, right? Because it's a cute array, there is a tree forming here. There is a tree forming. What is tree? What is tree? Like, let's say, so what I have done was I've added 0 in the beginning and 0 at the end. Now 0 is the biggest node. So if this is the array, what is the tree? 0, 3 goes to 2. Okay. And then 2 goes to 1. So that's the tree. Here, what is the tree? 2 goes to 3, 4 goes to 3, and then 3 goes to 3 comma 1 goes to 0. That is the tree here. Tejas, it seems more complex, but then based on cute array, I'm explaining f, guys. I'm explaining f. I want to show you people that even f is not demanding topics. Even f is not demanding. So f has cute array, and for cute array we can form a tree. We can form a tree for cute array. After forming tree, I'm trying to solve all the cases. Okay, it's difficult to explain. I have already explained f, but let me try to see if my solution is correct or not. If it's being wrong, I will try to code this for 30 minutes more. If it's being wrong, I will end the stream. If it is correct, I will solve one difficult problem. Okay, I get it. You guys can't do much when I'm trying to solve this, but then you guys can just stay and see. It's fine. So I will explain it once again because Tejas Katra was seeing. So if we have this tree, if we have this values tree, okay, if you have this values tree, let's say your L is here and your R is here. From L to R, all these subtrees also will come. For L to R, all these left subtrees also will come, right? From L to R range. But if a subtree is entirely within, you know its answer. All you have to find is for this thing, for this L, you want to get these things. You want to get these things. For this R, you want to get these things. Okay. So the answer that I currently have has from L and R, it has these things times S, it has these things times Z. So I have to subtract those two. Okay. How to subtract? How to subtract those two? L comma R, L comma R. Let's see, guys, if I will do this or not. L comma R, and then I have to subtract because this is being included from L. I'm doing pause R, right? So this is being included. Okay. I just want to subtract that. Now I can do this. Subtraction is difficult. What I have to do is I have to find. Okay, this is also difficult. 1 minute. What I have to do is We have to go to its parent, we have to go to its parent, we have to solve the problem for in between trees we have to take now. It seems difficult. So what I mean is, if you see the structure, see guys, these trees are like some segment trees, not segment trees, these are like same values, same values, same values. But then if you see some range L to R, how it appears here is L is here up to so on you go above, okay? But now there are some other trees here, smaller trees. Till here you have to take all the left things, but here you have to take this range, okay? So what you want is, I want this value. I want this value. So I want this node. I want this node, not just Z. I want this node and I want this node, okay? I want this node and then I want this node. I will subtract those things and then I will find the answer for, and then I will find the answer for L2 or Z. Not just L2 or Z, but L2 or Z and the middle things, okay? We have to find the answer for L2 or Z and the middle things. It's done, guys. It's done. Try to understand a little bit. Okay, it's being too complex. But then if you see, the first structure is from cute array, we can form some trees. And then what happened was, any range will become these things. Okay, I just want this, I just want this, and then I have to do this. This is nothing but, this is nothing but, that is nothing but this. Okay, to be done. But the other thing, I just have to find, it will be done in 2 minutes, 10 minutes at max. Okay, I won't explain much. Int Z. Okay, I have to do binary search to get, kth transistor is what I want. Okay, I want kth transistor. Okay, here I form the graph. Here I'm doing some DFS. Instead of kth transistor, I will just find the, so see, if this is Z, I will find the ancestor below that. Okay, find below ancestor. Okay, if this is just binary search, guys, this is binary search. I know this stream is being stupid, but I don't care because I'm at the end. Up of x of j. As long as this is happening, we can do x equals to up of x of j. Return x. So what are we doing here? We are trying to go above. This is z. We are trying to find this one. Okay, parent x, parent y. Parent x, parent y. What I should do is minus PR of minus parent x, okay, pl of parent y, and then I have to add get val of this, but not this. What I have to add here is I have to add I have to add in between the segment. You have L, you have R, you have some subtrace. I want to find the values of these subtrace and Z within these values. Okay, that's what I want. This is not complex, right? This is not complex. I want this subtrace. I want these things. Okay, we have Z. And then I want this, and then it's done. The problem is done. If I just have this, the problem is done. Do you guys get some idea? No, this is not binary lifting. I'm using binary lifting, but this is not binary lifting. Okay, I'm only using binary lifting to find the least common ancestor. But what is this is we are given some cute array, but then the array can be viewed as a tree. That's the idea. That's the good idea, right? I got the idea in the contest. The array can be viewed as a tree, and once you view as a tree, it's like a range. The range query is like you want something from the tree. Okay, so now you have this. So now what is left is you have this tree that represents some value, and that, see, you have values. If you take value x, it's start and end. All this value has a node. Okay, some things occur in between. Those are its children. What I mean is, if you take some green things, some particular value, some things appear entirely in between. Okay, some things appear entirely in between. Why? They can either be outside or they can be entirely inside. They cannot be here and here. Why? That contradicts the cute array, right? So that's why I'm making these things as children to the green. So I'm doing like that to solve the problem. So now I have to find the so now I have to find the yeah, C seemed okay-ish problem. It's like two necessary conditions and then it was done. One necessary condition is max less than or equals to max less than sum. The other necessary condition is at max two odd things you can take. Both are pretty obvious, and those necessary conditions were enough for it to be solved. But let me see if I can solve F, because currently very less people have solved F, right? And I think I can solve F. That's why let's try to just see that. I think within some debugging, 100 within 100% I can do the debugging. Okay. So now what? You have you have a range L. So now what? You have a range index L, you have an index R. You want the in-between subarrays values. Okay, you want the in-between subarrays values plus answer of Z. So write a function to get the in-between subarrays values. Okay. Write a function to get the in-between subarrays values. Okay. So B has in-between values. B has pref B of n. Let's just say pref B of n has children's summation of b's. Okay, B is just summation of children's b's. Now I will make pref B. Okay, pref B is prefix array of children, because now we have few children, right? Pref B is nothing but prefix array of children. And then what we should do? For children, we should do something greater than L. how to make it very clear. Instead of this, what I will do is, if x not equals to z, px equals to this. So what is this? Y is somewhere below. I am adding this part, and then now y is now this can be removed. Okay. If z is somewhere below, I am removing that part, and then now that can be removed. So in that way, I am coming up. So guys, when we are here, we have to add all the left subtrees. When we are here, we have to add all the right subtrees. So this sum will be given by pos or pos L. After removing these two, you will be left with the problem of from L to R, add in between subtree values, and then find the jets component. So we are about to be done. Try to understand slowly, guys. You guys can understand. It's just a bit difficult. So py, I'm removing from here to here. I have this thing. I have this thing. Now I just have to find this thing. Okay. After all that, these are all good programming practices. If I can solve this, otherwise these are bad programming practices. Now I have to solve between L and R, whatever the greater than L, less than R, whatever the children are, I will get those answers. Okay. Greater than L, less than or whatever the answers are. If L was equaling to Z, even then it works. Okay. Greater than L, less than or. I want those answers. Okay. Children's whose values are greater than L and less than or. Those things I want. Okay. I want summation of B's for that. To get summation of B, see, we have children. I want these children's summation of B. If I maintain prefix arrays, I can binary search to find these two things, and then I can get it, I think, right? How difficult can that implementation be? I want children less than or. Okay. And then I want to subtract children less than or equals to L. So I will add L plus 1, and then it will just be children less than L plus 1, right? So we want children summation of children's less than or. Okay. We want summation of children less than or. So get pref B will have children's prefix of B. Okay. So let's maintain prefix B. So now we have prefix B. After having prefix B, what do we want? Is I will get less than or. Okay, less than or, whatever the values are, I will try to get their summation. Okay. So this is just, we have some subtrees. See guys, parent node value is for cute arrays. For cute arrays, we can say for the value 3, 2 is the parent. Why? 3 contains entirely within 2. If you see, if here for 2, 3 is the parent, for 4, 3 is the parent, for both 4 comma 3, 3 is the parent. Okay. In that way, I'm forming that a tree. I'm forming a tree. Now we have the tree. Now any range we want odd occurring summation. I'm able to find that using the tree now. Okay. Because the problem says a weird property for an array called qt array, and you're given a qt array. That means we have to see the qt array properly. That's the first and direct step. It is, I have seen the qt array as a tree, then it was being simple. So now I want get less than or. Okay, int or int v. I want summation of b is less than or. Okay, int size equals to pref b of v dot size of. Okay, if size equals to 0, return, let's say there is nothing. Okay, now we have few children. We want to find the children. Left equals to -1, right equals to size, let's say. Okay, we want left, so right is assumed to be greater than or, let's say. Fuck, we also want its children. I will just take some index of a children. Okay, that's enough to binary search, right? Childs of v dot pushback of, I will just take some index of a children. Some index of a children can be idx of u of 0 or idx of u of back. Why? All the indices of children will be between these values. Okay, so first or last, anything works because all of them are in between. First one will work. So now I will use binary search to okay, if childs of mid, childs of v of mid. Okay, if childs of v of mid is less than or, then we have right equals to mid, else left equals to mid. So we are trying to come left. Okay, if left equals to -1, return 0, else return left is something that is actually less than or. Okay, if it is greater than or equals to or, then right equals to mid, else left equals to this. So left is something less than or. So because we have less than or, I just have to return pref b of left. So this will give me less than or. Okay, so now I am here. This value of L could be here or here, somewhere in between. Okay, so what I want is less than or minus less than or equals to L. I want less than or minus less than or equals to L. Okay, is L plus 1 NF? I don't think L plus 1 NF. Why? L can be somewhere here, but then okay, the subtree's first value will definitely be, the subtree's first value will definitely be less than or equals to L for all these things, right? For subtree's first value, because I'm adding first value, because I'm adding first value, it works. Okay, because I'm adding first value, it works. Why? The first value is less than or equals to this thing. Okay, so if I add L plus 1, that node will be removed, that subtree will be removed as we want. So what we want is onset plus equals to get less than or of z comma L, or minus get less than or z comma L plus 1 less than or equals to, or L will be removed. Okay, this children will be less than or equals to L, so it will be removed. We are good so far. And that's it. The answer is, this is the answer. How to output answer. Am I done? See, I'm using prefix arrays from root to here. I'm using prefix arrays to compute this red thing. To compute this red thing, I'm using from root to here prefix arrays, some prefix sum of some particular value. Okay. Something has gone wrong somewhere. Above, it looks like I haven't initialized things properly. These are not needed anymore. Line 252. What is the problem? Pos L is not declared. Pos L is declared, right? Is declared, right? Okay, what is pos L? It's just capital L, not pos L. Okay. See, it's not working. It's all zeros. Why is it all zeros? Let's look at parents, okay? Let's do a little bit of debugging. If I can solve this problem, it will be good. If you guys don't believe that I can solve, you can not view the video. If you are not understanding anything too, that's too fine. I'm trying to see the parent, okay? But if you try, you will understand. It's difficult, but you have to do it right. So let's see if our everything is working fine or not. So parents are not working fine. Okay. Parents are not working fine. Means fun is not doing its job correctly. Okay, why is fun not doing its job correctly? Fun tries to find fun is the thing that is forming the graph. What it tries to do is it tries to find one and one, right? Now in between, from this one to this one, if there is in between, it will try to process them and then add the biggest thing as a node. Okay, so now in between one and one you have two. So what it does is from two to two it takes, and then it adds a child from two to one. So what it is doing is, see, it's going over in between vertices, in between things. Okay, and then it adds from li or I from jr is idx of y dot back. So for 0 1 will be the thing, and then you process fun of a comma y. So when you process this thing, when you are here, you have this one. Between these two, you take 2 and then you try to find the last 2 and then you add 2 to 1. It's being weird, it's being wrong. So what we have to do here is, well, j less than r, well, j less than ri, j equals to jr plus 1. Okay, this has been missed. I have processed from here to here, then I have to go to the next thing, right? J equals to jr plus 1. See, this is j, this is jr. This is one thing. Next we have to process it. Still it's being weird, so let's again try to see it properly. Okay, so now what would be wrong? I will just output things here. Okay, see, li is a range. We have x, we have y. Try to understand a bit, guys. It's a bit difficult problem, we all know, but let's try to understand it a bit. I'm trying to code it, that's even worse, right? You guys are just watching me talk. What? It's never coming inside. Why is it never coming inside? We have this. Oh, am I never pushing? Am I never pushing into IDX? Okay, now we have our graph. See, parent of parent of 0 is minus 1. Let me keep that. Yeah, parent of 0 is minus 1. But again, it's telling everything's parent is 0. That's wrong again. So what happened now? So what happened? We have pushed these values and then we have called fun. Still we don't see this thing. Why don't we see this thing? So we have x as, okay, this is I minus 1, this is I. These kind of bugs you can't make in a contest. Okay, so now we are having our parents correctly. 0 has parent minus 1, 1 has parent 0, 2 has parent 1, 3 has parent 2. So this parent seems to be correct, right? And what about our answers? All of our answers seems to be 0 somehow. Why did that happen? So now we have our tree, guys. What is our tree? Our tree here is, in this case, our tree is, you have 3 here, and then you have 2 here, and then you have 1 here, and then you have 0 here. Okay. Okay. So I will once output b of v. B of 3 should be 3. B of 2 should be, b is like subtree sum. Okay, b of 2 represents this one and subtree sum of that is 2 is even, so we don't do anything. Also that should be 3. So let me output b of 3 to see if it's working fine. So B of this is 3, this is 3, all of them are 1, so that is also 3, so that seems to be fine. And then what happened? What about L of R? What about L of X? So leave these two. Let's see what about some. Okay, okay. What I have to do is I have to add the queries to. I think. So we have 3002. We should be getting this instead. So what went wrong from 7 to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Answer should be 3 plus 1 plus 4. Okay. 7 to 10, right? So 7 is here. Okay. 10 is here. Why? 7's color is 3, right? So I'm going to its color. 10's color is 1, right? So we are here. So now we have to come up. Come up. Okay. While coming up, let's output the values too. Okay. So what happened here? Answer equals to 3, it says. We have Rx. Why we have Rx? Because Y is already Z, right? Y is already here. We have Rx, and Rx says 3 and 0. Okay? Why? On summation of right side things of 2 is 2 2's are there. So it is 0. Answer of 3 is 3. That is correct. Both of them are correct. But what this seems to be have gone wrong, right? Get less than of a Z. See, this is supposed to go over once, and then it is okay. We have I missed this one. Plus get val of Z comma L comma R. Okay, this was missed. Will this work fine now? 4210. 4 is correct, but what about this 210? Do you have viewers? So first range is L comma 7 comma 10. The second range is 4 comma 9, it seems. Okay. Let me output L and R. I miss you more than you could know. 7 comma 10 is correct, and then we have 4 comma 9. That is correct. But if I mess up 4 comma 9's answer, all the queries also will go wrong, because 4 comma 9 answer is supposed to be 5 and not 2. So let's look at 4 comma 9. 4, 5, 6, 7, 8, 9. Right? 4 comma 9 answer is 3 plus 2. So 4 comma 9, where are we? 4 comma 9 We are in the same subtree. Same subtree, when we are in the same subtree, okay, we have these children completely inside. So that answer should be 3 plus 2. I am probably missing the 3. So now we have to output these things. Okay. So these things are wrong. Why? For 2, we should have had 3. We should have gotten 3 for 2. So at z equals 2. After 4, at z equals to say 0, comma 0. This should be wrong. Why? I will output 2's children. Okay. Should I output here 2's children's? Or I'll just, okay. So we have 2's children saying 5. So what is 5? Index of 3. Okay. 2's children is having that. And then you're binary searching on that with values 8, comma 4, comma 9. Okay. Okay, let's look at 9 itself. 5 is less than 9, right? So left should have been 0, right? What happened here? This is our binary search, right? What happened here? Is pref b value 0? So let's output pref b's 2, okay? So what about pref b? It is 3. This is also correct. So what went wrong here? L and R, I'm not changing L and R. L and R values I'm not changing. So what went wrong? Binary search. I miss you more than you could know. I'll just do the binary search here, okay? Two comma 9. 2 comma 5, right? 4 comma 9, so it's 5. From when did that go? So guys, what I was missing was this is our tree, this is our tree. So this I have added. We have added in between things. We have added these things too. Okay. But I just missed these right things and I just missed these left things. Okay, these left things and these right things are the only things I missed. Okay. So how to get these things? And these things is a question now. So for these things, it is just it's children's less than or, right? It's children's less than or. The fuck is this? Plus, so we can get children's less than or with get less than or of y comma or. Okay, it's just children's less than or. I just missed these things. And now we want these things. What are these things? It is plus get less than or of x comma, let's say n, entire, everything, minus get less than or of x comma. So this is L. Okay. You want to remove the smaller subtrace. If this is L, smaller subtrace will have definitely lesser L values, right? So this would work. Miss you more than you could know. 10-6. So we are doing it fine. For our purposes, let's just add these things too. Those are the only subtraces that were missed. Okay. For our debugging purpose, let me add those two. So what I have done, all these things I was able to add because I was maintaining uh, something to above. These are just right subtrees, right? Right subtrees, right subtrees, right subtrees. So with respect to this, the above right subtrees I'm adding. With respect to this, the above right subtrees I will store here. So here, what is stored here is with respect to this above right subtrees. But then these right subtrees are dependent on this value L. Okay, so we cannot store them. We have to compute them, and then we are computing them. What do you guys think of my programming skills? Am I worth doing a job? Well, see here L had 2. RX LY has 6. What is LY? LY is this. Okay, where LY is this. 4 plus 2 is LY. Because LY is these two things, addition. So now let first for suspense purpose, let me see the final test case working and then I will run everything. Okay. For the viewer's purpose. Now we have 303303. Do you guys think I will get this solution? I will get this answer right. Do you guys think I'm getting this right directly? Accepted. Because I'm just a low rated master, right? I could not be possibly solving this difficult problem. This is not even difficult for me. It was, I got the solution directly, but the implementation is heavy, right? It will go wrong. Why? So we are before system testing, guys. System testing is still going on. If it becomes done, do you guys think it will get accepted? Hello. Do you guys think it will get accepted? Like, it may have some wrong answer, right? But do you see the idea? You have a cute array. The idea is cute array can be represented as a tree. And if it is represented as a tree, now we have distinct values tree. It may or may not. But then the thing is, I read the problem and I didn't get scared of what if it is using some persistent segment tree. I don't know persistent segment tree. But before letting that thought happen, I should give importance to the line, right? Okay, why is this so specific? It is very specific that the array is cute. That means you have to use that. You have to solve the problem for a cute array. You should not solve the problem for any array. If you're using persistent segment tree, you will solve it for any array, but you have to solve the problem for cute array. Okay, what is so special about cute array? What is so special about cute array is if you see some red and green, all the red will appear in between greens. Like they will appear either here or either here. This gives you something to try. Why is this not coming? Okay, let me review the code. So what fun will do is fun will form the tree. Fun will form the parent. Fun will form the initial value of left and right array. Okay. Initial value of left and right array is what is left. I'll tell you clearly because you guys can go and see the code slowly and understand it slowly. So this is our tree, right? This is our tree. In this node, L of V is nothing but its parents left values, okay, and their children. So initially I'm storing parents left values. So parents left values will be number of parents before that, which will be I reminded 2 times x. Parents right, this is R of y. And then what will I do for L of V? For L of V, I will add previous children. For this children, I have to add previous children. So I will have this as L of V. And then I will make L of V plus equals to L of V. So this is previous children. Okay, previous children is possible. And then we have this. And then I will try to make, so now my L of V is very clearly defined. And then I will store summation of all these things so that I can subtract the Z, and then I will have all these things quicker. So it's just prefix arrays. Everywhere what I am using is prefix arrays. Binary lifting or LCA is one small thing. Least common ancestor is just to find. I'm using prefix arrays extensively. I'm trying to store something. And then I'm trying to get prefix arrays. On tree, I have a prefix array. For children, I have a prefix array. For many things, I have many prefix arrays. What the fuck? When can I submit? Guys, how long will it take? I should have super chat because I have 300, right? Oh, apply now. We crossed 300. So I think we are eligible. I can apply now. I'm very careful when it comes to legal issues. I have read all of that. You don't know how fast I can read. Miss you more than you could know. Does my channel start with UC? I don't know. They gave me the link, so that should be fine. So where are my most viewers? Are they in India? I read all of this too, guys. Don't worry about me. PG. I'm showing in a PG. It can tomorrow, guys. You guys can. We can. I can probably see it tomorrow. Okay. So if we leave that, is this ready now? It's ready now. What may go wrong? Anything can go wrong because you guys have seen so many bugs, right? But why are they going wrong? Why? I can't debug. 99th numbers. Fuck, guys. It should be correct. 99 means it should be correct, right? There is some small bug because logically it's working well. There should be one small bug. How can I find that now? 99th number. Review code review, guys. Let's review the code. Am I deleting everything? Am I clearing everything? Miss you more than you could know. I'm clearing everything. I am only going over. Everything should be correct. There might be some small error. Okay, Rx minus Px is perfectly giving me these things. Okay. 1 minute. Okay, no, 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 no. It's giving me perfectly those things. Is there any one case that I might be missing? Timer is 0. We have LCA correct. LCA was copy pasted. Find child was written by me, which keeps going above as long as we don't cross Z. Okay. Why? Everything below Z is not an ancestor to Z. Everything above Z is an ancestor to Z. So as long as it's not an ancestor, it keeps going above. Pref B is also correct. IDX has just some IDX. I mean, just some IDX of children, what can we do? For L, I'm trying to take everything on this side, right? So I'm trying to get sum of all the children with value less than L has been removed. So you have all these children. Wait a minute. Can this be an issue? Should it be n plus 1? I don't think this case can occur though. Why? You have 0, let's say you have 1, let's say, okay? Miss you more than you can know. Maybe that should be n plus 1. Because less than n is wrong, right? Can I devise a case where it fails? Let me think of a case where it fails. Okay. 1, 1, 2, 2. N is 4. Q is 1. Okay. Now what will I do? Nah. Okay. L and R. Both of them will be. It won't. It won't. It won't happen. Why? It, this is the last thing. This is the last thing. that's being missed out. Light, I'll try to see it. But seems solution seems correct, right? The idea. We'll never know unless we get a correct answer, right? Any idea how to get the test case? Maybe it's impossible. So let's see for the pattern. Someone is suggesting, right? So it's one, it's two, it's three. So stress testing is what we can do. I never done that. Should I try that? Generate random permutations and see where it fails or something like that. If one thing goes wrong, everything goes wrong after that. But then we have x, we have y, we have answer, previous answer. Why anything should go wrong? Nothing should go wrong, right? Let me just review the code once again as it is small. Let me remove unnecessary things. Okay, let's have unnecessary things. All the variables are being resetted, right? B or L are being resetted. Okay, IDX adjacent being resetted. Parents have also been resetted. I'll just do one additional thing just for no reason. Clearing everything after that too. Okay. And then what? Let's verify this function fun. What does fun do? Currently, it's processing the node with values x. So it's trying to go between those two things. Okay. It's trying to go between those two things. And then it's keeping li plus 1 as the next index between those two. If it is there, what is its value? If its value is y, we are trying to find the last y because it should be in between. It cannot be outside. Why? It should be in between. Okay. If it is outside, it's not a queued array. It's in between. So now this is a node, and y I'm making parent of y as x. What for y L of y is number of things on left side, and that is I reminded too. R of y is number of things on this side, number of x's on this side. So this is also right. Parent of y is x. So these three things were perfect. Adjacent of what case could I be missing? No cases, I think. I think no cases. See, here it's very specific. Very specific. X not equals to z means what? X not equals to z means you have x here, you have z here. There is something in between two, which is px. What if px equals to x? What if that happens? If px equals to x, this will be gone. Okay. What happens to this one? We get answer of x. And then what happens to this one? We get things that are less than x. That works out. If py equals to y2, this works out. Miss you more than you could know. This is correct, right? XLR is just like upper bound minus lower bound, len reminder 2 times x. So this is the above chain, guys. That is the above chain till z. Okay, this is for x. I'm trying to find its count, its contribution, and then we have its right side children's, their contribution is getting from this binary search. Okay, from there, what am I removing is I'm removing L, the smaller subs before this L, whatever the subtrees are, their contribution I'm removing. Okay, code is small, code is not that big. Or Z. How to think of this odd Z ones? What is odd Z? This is Y, right? Odd Z is this value, this thing. Okay, why? If there are some Z's in between, we should consider them in Z, but we should not consider this subtree. For that reason, I'm just keeping that odd Z. Okay, we should not consider this subtree. We should just not consider this subtree. Okay, that's why we're keeping that. What about this side? We have somewhere L here, and then we are doing L plus 1. But this subtree itself is already even lesser, right? So L plus 1, this will be less than L plus 1. So that will be removed too. So this is also correct. But there can be some error because I don't know. We have found so many errors, right? Bro, this should be correct. This should be right. Should I end the stream? For L of B is above things plus whatever the previous L's. Okay, for the children. Wait, is this DFS wrong? I'm doubting DFS now. What does DFS do? It finds. What does DFS do? Okay, this DFS seems to be wrong, right? The DFS finds B for all the children. Now, after that, we can make L of U's and L of B's for all the children too. Okay. But now this is the order of leaving the tree. And while leaving the tree, this is wrong. This cannot be done. While leaving the tree, I'm just adding the above thing. So this will only have the above thing. This is when we are leaving the tree. Guys, this is an error. Only this is an error. I doubted that. I have tried verifying that, but still I don't know why I haven't done that. I doubted that, guys. I doubted that. But then I don't know why I haven't verified that. That is definitely an error. Otherwise, it will only have these two things, these two things. It should have prefix array from the top to bottom. I am feeling this will get accepted. If this gets accepted, will I be the one of 24 people to get to solve this problem? See? So I can flex now that I am one of 24 people that are solving this problem by now. Do you guys see that? Pro coder. I hope it don't go TLE or some shit. I'll get some water to celebrate my achievement. Really, Pradeep KR? I don't see you, Pradeep KR. I'm gonna be in that 24. Okay. Guys, do you see how I can solve the problems? So you guys should realize you guys are getting advice from someone who can solve such difficult problems so easily on streams. Q they have this string of distinct values. So let's look at this tree of indices. I've tried something. Let's try seg tree. Came here. A tree node represents LR segment where L and R are ends of some value X. Then we have this tree. And once we have this tree, we can solve the problem. See? Clearly define whatever the fuck you are maintaining. This is just the tree formation. And then define whatever you are maintaining. Pause cell, pause, or few other things. And then I had to do binary search. So within the range, less than or. This is just the LCA. Don't say this is binary lifting. This is solving the problem. This is solving this problem. Okay. Once you solve this problem, see, don't ever, the solution was easy. The thing is, implementations, I'm trying to explain you people, that's why I'm just taking it slow. But then if my implementations was like, the thing is, it's only using prefix arrays, right? Binary search and prefix arrays. But we have to be very careful at things. See, if you can write the structure as generally as possible, then you can solve it without errors. If you're writing the structure as generally as possible, this is X, okay? This is Z, okay? And this is Y, okay? What am I maintaining in Y is, because Y in Y, L of Y has these things plus this part. So that is L of Y is having. So we have to find this Py. Till here we have to find the values, because then we will have all these things, because this will have the value of these things plus this. So till here we want to find the value, then we have that. And then I missed these things, I have added that. And then I missed these things, I have added that. And then we have these things, and then we have to define for Z, we have to find in between subtrees. So it's not like unsolvable, right? But still I solved it easily, right? I solved it on stream, I solved it while explaining. But how I solved it is, it got solved instantly. You can go back in the video and check. It got solved instantly, like, because I was spending my time on E. I wanted to implement EF in the contest itself, but I was not able to. We made it 24. I don't think 10 seconds is needed for this solution. It's 2 seconds or something. See? So guys, I spent some time on E. See, I spent quite amount of time on E. And then I realized, why not read F? I told myself I'm not scared of F, okay? If you see my video, okay, where are we? This is, how long is it? Wait, I took what? I took all of this time? Just this was, how many hours did I take? It's just 12 o'clock, right? 11, 12, two more hours. Why is it here? Okay, this live is about my life, I guess. Hey, anyone is there? Yeah, I want to make a video on that, guys. What should be the steps to be followed to solve any problem? Because I can solve any problem, right? I have a plan to make a video on that, like 15 minutes video. The first step is giving importance to problem, but the first step is trying to state problem statement as well as you can. Trying to state problem statement as well as you can. You have to add an additional line that if there is a simple solution which can be proved, what would that be? Like, it's not thinking habit, it's like, see, it's not even just thinking. If you can follow few rules like reading the problem well, try to understand the problem well, have that hope, have that positivity, have that, if you believe golden rules too, you can solve well. But then you guys cannot believe them, so I thought I will try to make three steps to solve any problem. The first step is problem statement plus, if there is a simple solution, what would it be? This question you have to add to the problem statement, okay? Then you can directly say, I was directly able to say on C that, on D, that it is some brute force DP. Why? Why was I able to say that? I tried seeing a test case where this is 1E9 and this is 1E9, okay? If both of them are 1E9, they should be together. And then you have these things. So now you must solve the problem of grouping these things, okay? I wrote two things for D. Okay. Is there something nice? Or is the see all the problems, all the minimization problems are either finding lower bounds or brute forcing the structure. Okay, DP means brute forcing the structure. Structure means all possible things are there. Now you cover all of them. So in this case, the structure is nothing but few things greater than size 2 will become equal. Few things greater than size 2 will become equal. This is the structure. Okay, and then you can question for these things becoming equal, what is the answer? All of them should become their median, because that is a very famous problem. That's an easy problem. If they are not median, you can move here and then it becomes better. And then okay, if the size is greater than 4, you can break it further, because if the size is greater than 4, you can break it into 2 comma remaining, so that you have a better answer. So the problem is done. The problem is the structure is less than or equals to three things. Structure is less than or equals to three things. If you have less than or equals to three things, you can brute force them. You can do DP. See, less than or equals to three things. I'm just taking two things, last three things, and then it's done. And what are these things? Because it's a cyclic array, I assume that this and this will be combined. So we have in between array. So this combined plus in between. So if you have a linear answer, you can find for cyclic answer too. Done. Do you guys get me? Is there meta hacker cup? I have to. I missed it last year meta hacker cup. I don't want to miss this year. So guys, that's it. Check out my videos. I won't explain more here. That's it. Bye. I have to eat food at least. So do you guys see how I solved F? There is no other Indian post contest discussion that's solving F on the stream. Okay. I commented on D. Let me comment on C. C was few necessary conditions and then brute forcing done. What about B? B was nice. Just see that it is bitwise. If you see that it's bitwise, it's done. B was nice. What about A? A also lower bound. Lower bound. Answer less upper bound. Number of distinct values. Because it's maximization problem, right? And that's possible. So that's the answer. Done. So you come to D. It's a minimization. It's like asking you to find minimum. So because it's asking you to minimum, if it's nice, the answer should be 0. This indicates maybe some thing brute force or greedy. Okay, leave that. You add something. So what I mean is, I thought like you make AI and the before thing equal or AI and the next thing equal, but not that. Can you brute force structure? Is the question you have to ask. This is nothing but DP. Can you brute force the structure? Is DP. You guys think of state transitions and all, but then you don't do the work that is actually needed, because you guys see all the videos that exist on YouTube are all bad way of teaching. Like they do bad teaching. If you follow their ways, you can never improve on your own. Okay, my way of teaching is something you can improve on your own. It may be more difficult, but then the way I teach is you can go on your own. Okay, structures, because I don't want you people to see my videos too. You guys should be able to do it on your own. If you have the hope, if you try it well, you guys can do it on your own. I have done everything on my own. I haven't seen any videos. I haven't. I kept trying, and then I kept learning few things. Right. Even today, maybe I have learned something by solving F. Being one of the 24 people in the world has solved this problem so far. Someone else has solved it. Fine. Where am I? Here. In terms of solution size, ours is big. This guy had very small solution because he's Rainbow. Okay. We don't understand his solution, but he has very small solution. Fuck. Mine is big because I have comments too. Not just that. But my solution is simpler to me, okay? All of them have simpler solutions or what? Can I understand this? Maybe maybe they have done in some other way. I have formed the tree and then I have done it, okay? I have made the tree and then I have done it because I have seen it like a tree. So for D, because someone has asked me, you want to see the structure. What is the structure of optimal? Some things of size greater than 1 become equal. Some things of size greater than 1 become equal. Guys, I'm ending the stream. I'm tired. See, the thing is, you can't even see well the problems you already solved. Don't talk about problems you cannot solve, okay? The problems you solve itself, you solve them in a shitty way. You don't try to screw them clearly. You don't try to first try to do what you're doing well. Please, that's I'm answering you only, bro. Yeah, we select two odd number of things. So something that occurred odd number of times, we select two of them. Selecting max is best, right? There is video already. You guys you can go back again. But what will you do when you guys stuck on some problem when it's like simply solving and can't able to solve it? I tried after some days. I haven't solved E, right? But then that doesn't mean I cannot solve F. E, I have no idea. But F, I was able to solve. See, F, I was able to solve instantly. Can I add a tag on that? What is the idea? It's just a tree. Like, okay, bye guys. See my other streams, bro. You need not ask me directly. I might have answered it somewhere. Have patience, see it somehow, understand and improve somehow. Bye. I'm ending. Like the video, guys. Yeah, that's gay, Susan, but fine. Bye. తెలుగులో ఏం చేయాలా నాకు తెలుగు నేను తెలుగులోనే మాట్లాడతాను నేను నెల్లూరు నుంచి కాబట్టి